In the previous video, we worked example problems where we used integration to find areas between curves. And so now in this video, what we're going to do is we're going to take a look at a word problem that will give us a sense for how areas between curves can represent something or some quantity in real life. So like if the curves that we're finding the area between, if those curves actually mean something in business, engineering, biology, etc. All right, so it says two cars, A and B, start side by side and accelerate from rest. The figure shows the graphs of their velocity functions. All right, so we've got car A and car B, and each car has a velocity versus time graph. The cars start with velocity 0. They start from rest at time t is equal to 0. And then for any time greater than 0, you can see each car's velocity. Now, this is going to be a simple case of just straight line motion, not necessarily left to right, just a straight line motion. And furthermore, the velocities in this case are always positive. If they were negative, then like for straight line motion, positive velocity means like you're moving, let's say that's the positive direction. Negative velocity would mean you're moving in the opposite direction. But here, it's going to be straight line motion and you're only moving in one direction. You're either not moving, which is at time t is equal to 0, or you're moving with a velocity in one direction, the positive direction for both cars. All right, which car is ahead after 1 minute? Explain. So, okay, we also know that the area under a velocity versus time curve over some time interval represents the net displacement of that object over that time interval. And I'm not saying distance traveled by that object, because technically if you had a velocity versus time curve that went something like this, and you were trying to find and you were integrating so this is velocity and time, and you were integrating from like here to here for these two times, then we know the definite integral, it's the net area. It's this area minus this area. And what that means is, so the car was traveling in the positive direction from here to here, and then it was traveling in the negative direction from here to here. So maybe it came back to like here. And what this integral represents is you take this position and subtract it from this position. It's the net displacement. So you could have a net displacement of 0 if you have positive and negative velocities, if you're integrating positive and negative velocities. Okay, but here we're not dealing with net displacement because the velocities are always the same sign. They're always positive in this case. So in this case, the area under any portion of either of these velocity curves over some time interval is the distance traveled in that time interval. Okay, so part A, what car is ahead after 1 minute? Well, we can see by intuition that, so they both start from rest. Again, they're traveling in the same direction. They're never traveling backwards. So the car A has its velocity overall is bigger than car B's velocity for that 1 minute interval. So car A has to be ahead of car B. Okay, so car A is ahead of car B. But if we try and answer that, give a more descriptive answer, then what we could say is that the area under the curve between the time curve and the car A's velocity curve is greater than the area under car B's curve for the time interval 0 to 1. So the distance traveled by car A is greater than that traveled by car B. So car A is ahead. All right, what is the meaning of the area of the shaded region? So what does this mean? This area? Well, that's easy. We can see what it is. It's the area under the curve, under curve A, velocity curve A, minus the area under velocity curve B. You subtract those two areas and you get this area. Okay, so what is the area under curve A? It's the distance traveled by car A. What is the area under curve B? It's the distance traveled by car B in that first minute. So this area then is the distance between car A and car B at time t is equal to 1 minute. Distance between car A and car B after 1 minute. Okay? which car is ahead after 2 minutes. So which car is ahead after 2 minutes? What we need to do is, if we knew this area, all we need to do, we don't need to know what this area is. We just need to know which area is larger, this area or this area. And it looks like this area is larger because this area represents how far car A is ahead of car B after 1 minute. This area would represent, since car B is traveling faster, this represents how much further car B traveled than car A over this time interval. And so if these areas were exactly the same, then car B just got even with car A at time t is equal to 2. It looks like this area is less, so car B caught up to car A after time t is equal to 1 minute, but car B still hasn't reached car A. And I think you could say that this area looks to be a little bit bigger than this area. So car A is still ahead. All right. Estimate the time at which the cars are again side by side. So let's do, okay, so all right, so to estimate when the cars are side by side, what we're trying to do is find at what time does the area between these curves, as it adds up, at what time does it, boom, now this area is equal to this area. And so they don't give us these functions, but we can do an approximate area under curve, so like an approximate integration. And we'll use, to do approximate integrations, you want to use the midpoint rule. So we'll break this up into pieces, like each tick mark will be a piece. And so, yeah, each tick mark is a delta x. And so the height of the rectangle within each interval is going to be the function evaluated at the midpoint. So let's see, the pink curve, there's the midpoint. Okay, now the second interval, there's the midpoint. Okay, third interval, there's the midpoint. Okay. Okay. And then we know we're most likely going to have to go past time t is equal to 2. So let's go 2 blocks past to start. So there we go. Okay. So I guess let's start by just going from 0 to 2 of VA dt is approximately equal to, so each of these is 1/4. Each of these ticks is 1/4 of a minute. And then the velocity, it doesn't give us the velocity, so this is purely for comparison. So we're just going to assume this is like 1 velocity unit, 2, 3, 4, 5. It's just whatever this velocity unit is. So, all right. So each block width is 1/4. So now the height here would be, looks like about 0.7. Here it's about 1.7. Here it's about, so 2.25. Here it's about 2.75. Here it's about 3.2. Here, about 3.5. Here, 3.8. Here, about 4. Just 4, really. Okay, yeah, that's from 0 to 2. Okay, so this is 0.7 plus 1.7 plus 2.25 plus 2.75 plus 3.2 plus 3.5, 4 divided by 4, 5.48. Again, these have no units. These are just numbers that we're going to use to compare. car A and car B. So now we're going to go from 0 to 2. VB dt is approximately equal to 1/4. Okay, so looks like about right there. Pretty much nothing. Okay. 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 Okay, so we've got, looks like just 0.1 and then 0.4 and then 1.1 and then 2.4 and then 3.5 and then 4.05 really, if anything. Then 4.5 and then 4.9. So, okay, 0.1 plus 0.4 plus 1.1 plus 2.4 plus 3.5 plus 4.05 plus 4.5 plus 4.9 divided by 4, 5.24. So it's pretty close, but it'll go a little bit past 2 minutes. So if we're using the midpoint rule, it looks like they'll meet up somewhere within this interval from 2 to 2.25 minutes. And we can figure this out by, so we've got 5.48. So for the car A, 5.48, that's the distance traveled in some unit. And then we're adding to that. So car A is in pink. We're adding to that. We're going to say 4.2 times, some time. We'll call it delta t. This is going to be a time after 2 minutes. 5.48 plus 4.2 times some delta t. That's going to be equal to 5.24 plus, well, this is looks like 5.2 as 5.2 times that same delta t. And when we get that delta t, we'll just add that to 2, and that'll be the time. You see? So 5.2 minus 4.2 is just 1. So we've got delta t is equal to, and then it's going to be 5.48 minus 5.24. 0.24. So this part D then is equal to about 2.24 minutes. So right when it gets to this point here, that's when these areas are approximately equal.